Continuing on with our lesson 13.3, I'm going to be talking about reference angles here. First I'm going to show you why reference angles are so cool and useful, then I'm going to show you how to find them. So if we go back to our unit circle, we can see here that we are looking at a couple different angles. We have a 30-degree angle in here, which is mirrored over here actually. There's another 30-degree angle which is created by this 150-degree angle. We have a 150-degree angle as our terminal side. It actually creates a little 30-degree angle over here. Now looking back at our unit circle then, our 150-degree spot and our 30-degree spot, they both end up at points on the edge of the circle like this where the coordinates actually correspond. Here we have a root 3 over 2 as our x-coordinate. Here we have a negative root 3 over 2 as our x-coordinate. Here we have a 1/2 as our y. Again, we have 1/2 as our y. And so those correspond due to the fact that they both have 30 degrees as their angle coming up from the x-axis. Now looking below as well, here we have another 30-degree spot. Which means that in total, coming all the way around to here, this one is actually, if you remember, this is our 210-degree angle. Now at 210, we draw our point there. Similarly, our coordinates is going to be negative 3 over 2, negative 1/2. It's going to be the same values as what we had up here. At least x-wise, it's still just as far to the left of our origin, but it's our y value flipped. It goes 1/2 downward, and that's where we get the negative 1/2, and that's where we get the negative root 3 over 2. Now looking at our furthest one away, over here we have another 30-degree angle coming down from our positive x-axis, which means that if we come all the way around to here, what that gives us in the end is a 330-degree angle in total, all the way around. Now again, the points that it lies at, our x amount away is going to be root 3 over 2. Our y coordinate is going to be negative 1/2. Now, funny thing about all these, the coordinates that we have there, those correspond to the cosine at that point and the sine at that point. So if you remember, the cosine of 30 degrees equals root 3 over 2. And so the cosine at our 30 degrees is root 3 over 2. Similarly then, if we are looking at our 150-degree angle, we would say the cosine of 150 degrees equals, we would look at our x portion and say that it's negative root 3 over 2. So it's nice to know that all of these are only 30 degrees in between each, but they all share the root 3 over 2, some positive, some negative, as their x value, and a 1/2, again, some positive, some negative, as their y value. Remember, y corresponds to the sine, x corresponds to the cosine. So that's where these reference angles come from. The reference angle of 150 degrees is 30. Same with the reference angle of 210, again, it's 30. Reference angle of, this should be 330 is, again, 30. Since we know the reference angle of each of them, we can more quickly find out our sine and our cosine. All we have to know then is in the second quadrant over here, cosine is going to be negative, sine is positive. In the third quadrant down here, both cosine is negative and sine is negative. In our fourth quadrant here, the cosine is positive, sine is negative, And our reference angle is always going to be the angle that's in the first quadrant here, where both are positive. Cosine is positive and our sine is positive. So we can go from our positive reference angle, find the positive cosine, the positive sine, and we can determine any of these knowing which one is either positive or negative. So that's why the reference angles are so useful. This is how we find them. If we are given a theta in quadrant 1, our reference angle is just that angle. So that one's pretty easy. If our angle given to us comes out into the second quadrant, our reference angle is going to be this little piece over here, and we can find that by doing 180 minus our angle. So again, in our example, we had 150 degrees. So we do 180 minus 50, so our reference angle here became 30 degrees. Similarly, if we have an angle that's so big it gets extra wide here, it goes down into the third quadrant, we would have to do whatever our angle was. So say, again, for example, we had 210. 210 goes into the third quadrant, goes beyond that 180, so we'd have to do 210 minus 180, which leaves us with another 30. That's where this angle comes from. Our reference angle is, again, 30. And one last one. If our reference angle, again, comes all the way around so that it gets into the fourth quadrant, so our example in this case was 330 degrees, comes all the way back around, the reference angle that it makes is this little piece coming down from the x-axis, and it is 30. And how we found that was 360 minus our theta, or 360 minus 330, which equals our reference angle of 30 degrees. So it's always good to know these reference angles because they can help us find the sine and cosines of whatever angles we're dealing with. So if we have theta sub r, which is our subscript or our denotation of reference angles, we just need to find the reference angle for each of the following angles. So in this case we have the angle of 160. We'll draw it in standard position. Again, if it was straight up and down, it would be 90 is up here. Over here would be 180. So it's going to be a little bit less than 180. This is going to make our 160 degrees. So to find what our reference angle, remember we want this angle here, we would do 180 minus 160 equals 20 degrees. So our reference angle is 20 degrees. So again, the sine of 20 degrees and the sine of 160 degrees are going to be the same exact thing. The sine of 20 degrees, or the cosine of 20 degrees is going to be positive, and the cosine of 160 degrees is going to be negative, but they're going to be the same number. One is positive, one is negative. If we have negative 110, so again, instead of going this way, like we normally do, we need to go downwards because it is a negative. So again, if it was straight up and down, or should I say more down, that would be negative 90. So we're going to go a little bit past negative 90. So that is our negative 110 degree angle. So our reference angle, remember, always comes down from the x-axis. So we need to know this angle. It might be easier for you to find out what this angle is first. So we would say 360 minus 110 comes out to 250. So this is a 250 degree angle because 250 is coterminal to this 110 degrees. Now that we have 250, we can say 250 minus 180. That's going to be our way of finding the reference angle here. It's going to come out to 70 degrees. So our reference angle here is 70 degrees. So again, all three are 250 degrees, negative 110 degrees, and our 70 degrees, they're all going to have the same values for sine and cosine. It's just that the 250 and the negative 110, those ones are going to be negative values, whereas the 70, both of them are going to be positive values. Now let's look at 275, again in standard position. Straight up would be 90, straight to the left would be 180, straight down would come all the way around to 270, and we're at 275, so we need a little bit more than 275. So that's going to be our angle, 275 degrees. So again, in this case, our reference angle needs to be this piece, coming straight down from the x-axis, in which case our way of finding that is we want to do 360 minus 275, which in the end is going to leave us with 85 degrees. So 85 is our reference angle for 275. This last one may be a little bit tricky because it's given to us in radians. We have negative 3 pi over 4, which it might be best to find that in its positive coterminal value. So we would do negative 3 pi over 4 plus 2 pi. That's going to give us our positive coterminal value. So that's actually going to come out to 5 pi over 4. So we can use that value instead. So starting from our initial side in standard form all the way over here, this all the way around is our 5 pi over 4. If we went this way around, this is our negative 3 pi over 4. So they're the same exact angle. Either way works. We just need to find now what the reference angle is. Just like before, when using degrees or in using radians, the reference angle comes straight down from our x-axis. So if we wanted to find our reference angle before, we did something like this. We took our angle that was given and subtracted 180 degrees. So in this case, we do the angle given, 5 pi over 4, and we're going to subtract not 180 degrees, but over here in radians is actually pi. So we would subtract 1 pi here, or I'm just going to quickly change that to 4 pi over 4, because 4 over 4 is still 1, in which case 5 pi over 4 minus 4 pi over 4 comes to 1 pi, or just pi, over 4. So our reference angle is going to be pi over 4. And that's how we would find reference angles.